Alright, so I'm going to be going over some of the components in an air conditioning system and identifying them as to what they are and where they would be in the system and what their purpose is. So the first one we're going to look at is the orifice tube. Alright, so this is one of the dividers between the high pressure system and the low pressure system. They are color coded. The color of the orifice tube identifies it as to what the size of the opening is. All right, it is also usually identified when you look at the low pressure pipe. It fits in a straight section, and the straight section will have a little bit of a crimp. Another way, the purpose of the crimp is to stop the orifice tube from going too far down the tube. And another thing that will kind of give you an indication that it is an orifice tube is that we will go from a small diameter high pressure pipe to a large diameter low pressure pipe. Something else that will identify the orifice tube is the fact that in one straight section of pipe we have two hose connections for my gauges or my machine that will allow both the low and the high pressure connections to be made. Now this one is a little different, and you don't see this very often. This is a two size or a variable size orifice tube, and it was used for high demands on some of the bigger cars, where what they would allow it to do is when you request a high demand, it would shuttle across and allow a bigger orifice to allow more refrigerant to travel through. So this is a TXV, and that is the other style of pressure reduction at the high pressure to the low pressure side. Again, we have the smaller diameter high pressure side and the large diameter low pressure side. And what happens is the refrigerant coming through has to pass through a needle, and that's where we get the pressure reduction. There's one that is all together, not cut away. This one is a very old style, and you do still see them around in some things, more along the lines of maybe a reefer on the front. But this is an externally balanced TXV. What we use is a temperature sensing bulb located on the low pressure outlet pipe, and we then use a pressure pipe looking at, so one tube is reading the pressure in the gas, and the other is reading the temperature in the gas on the outlet. My refrigerant coming in, this simply moves up and down. So that is basically the same thing as my H-block TXV, except that now instead of having these external tubes on here, that we have it all done in the H-block. Okay, so depending on the system, we will have this component, right? We have one here that's a little more dressed up. It's got insulation around the outside of it. You can see that we have a pressure switch still mounted to it, and we have connections for the gas coming in and out. This is an accumulator, same as this, and I'm going to take it apart and show you what's on the inside. On the inside, we have a desiccant that will absorb any water that is in the system. And I use the term water specifically. We do not refer to the liquid refrigerant as a liquid. It still could be a liquid, so we want to make sure that we're absorbing the water in here. Now the way that this works, I'm going to remove the desiccant, and it might be a little difficult to see, but this U-shaped pipe that's coming in here, the gas entering here, we don't want the gas to go straight through and out to the other side, so it hits the deflector. The deflector deflects the gas down to the bottom. One tube is connected to my outlet, and it comes in and down and around and up, and it's basically, think of it like a straw where it's stuck up and the end of the straw is sticking to the top. That is to ensure that it pulls gas from the top of the accumulator down through and to my outlet. We do not want any liquid refrigerant going in here. We want to make sure that it's all gas. At the bottom end of this, we have a little screen on here, and that is because there is a hole. The refrigerant changes state from liquid to gas in my air conditioning system, but the lubricant in the refrigerant does not change state. So there is a small hole in here through the screen so that it can draw oil that will be building up in the bottom of this container and allow it to travel through with my refrigerant. Now, on systems that use a TXV, they do not use an accumulator, they use a receiver dryer. And we'll talk about where the differences are in the system and why we use each one. This does essentially the same thing. It contains a desiccant in here, and the refrigerant simply is directed into the top. We have an in marked on the top here. The refrigerant is directed through. It passes through a rough screen at first, then a fine screen and the desiccant, which acts as a filter, and it collects at the bottom. This pipe, make sure you can turn it here, this pipe is sitting into the bottom, and this is connected to my outlet. So it's on the pressure side, and we put liquid refrigerant in and liquid refrigerant out. Located in the top of some of the bigger ones, you will see that it has a sight glass. The sight glass is there to, we can use that for monitoring the refrigerant level and basically doing kind of a visual inspection as the refrigerant is moving past. Now, on smaller vehicles and newer vehicles, they have reduced the size of the receiver dryer, and there's, just to give you an idea, now this one does not have a sight glass, but it still has the straw going down to the bottom, or pipe, which is picking up liquid refrigerant in it. On some of the smaller cars, this is actually built into the side of the condenser, on the front of the condenser, so that it's out of the way and it's basically non-serviceable. So here are two styles of condenser cores. They basically are aluminum at the front of the engine, have good airflow over them. We have a couple of different styles. This is a tube and fin style, where the tubes are very large and the refrigerant passes through them, and we have a lot of fins contact on here. They can become very damaged. In this case, the fins are a little larger, but the orifices, or the ports where the refrigerant flow through, are much smaller and wider. For the evaporators, we have a couple of different styles that I want to go over. This one will just show you that, and again, we have this set up where you can see that there's a bit of, at one end here, we have very large holes. All right, and at the other end, it's actually blocked off. The reason for that is so that we force the refrigerant to go across in one section and then flow back down through and cross multiple times over the evaporator. All right, the same thing can be done with the condenser, depending on how they block it off at the end. So this one is kind of a plate style. You can see the area that we have where the refrigerant flows through, and lots of contact with lots of fins. The reason for that is these tend to be very thick and very small, because these are going in front of your heater plenum, so they have to be pretty small. Compare that to a condenser where it's going across the front of the vehicle. This is a plate and fin design, same sort of thing as what we just looked at. Very compact, but much thicker. The air moving through here, we have lots of aluminum fin contact for the heat to transfer off. This one is a tube and fin design, and similar to what we did in the other condenser where we blocked it off. This one, the refrigerant coming in would be on the small pipe. We have several small feeder tubes that come off of that, and it feeds into different tubes as it's crossing here. They are designed then to go across and back and forth, and you can see they go back and forth multiple times across the evaporator core, That one's quite damaged. All right, and there's the other end. So these are some of the compressors we will use on our system. Now this is probably one of the oldest ones. You won't see this anymore. They've stopped using them, but we're going to discuss it. This is a piston type compressor. It is a radial piston, and they were used on a bunch of GMs for a long period of time. They simply sat on the front. Here's one with the cover off. When we say piston style compressors or radial pistons, there has 4 pistons, and as we turn this, a cam rolls around, and when one piston is moving out, the other piston is moving in. There is a set of reed valves. One would be on the outside and one on the top of the piston, and as it is moving down, the low pressure gas on the inside would lift this reed valve off its seat and allow the gas to come above the piston. When the piston starts moving back up in the cylinder bore, this reed valve seats, and the other reed valve in the cup built into the cover would open and allow the gas to be pushed out. Remember that pumps create flow; they don't create pressure. All right, that's the first one. This is a rotary style pump, very similar to what we talked about in level 1 fluid power. This is a balanced vane style pump. Now the vanes are seized, but as it would turn, the vanes could spin out, grab the refrigerant, move it along, and push it through the compressor that way. This is another piston style pump. This is kind of designed like a small 2-cylinder air compressor, right? We have 2 very small cylinders in here. We have, again, a set of reed valves located on the top. When it is being driven, the pistons simply move up and down. Refrigerant enters through the bottom and keeps the crankshaft and the connecting rods lubricated, and everything works out. So this is a type of piston pump where it's connected to a wobble plate, and I call it a wobble plate because it has the ability to actually change position and allow a different length of stroke for the output of my piston. The advantage of that is that when I don't need my compressor to be working at a full volume, I can actually reduce the flow and continue to drive it so that I'm not starting and stopping the compressor and putting a load on and off the engine. This is slightly different, and I hope everybody can pick this up on the video. This is a swash plate. On this one, we have double-ended pistons. So as I turn it, right, you can see the pistons moving back and forth, but they are designed with valves on each end so that as one piston is moving back, it is drawing in refrigerant here, and then when it gets to the bottom, it stops and goes the other way, and it's pushing refrigerant out here now, but it's also drawing refrigerant in on this side as well. So what we end up with 5 pistons located around there is actually a 10-cylinder engine or 10 cylinders working for me, so that I get a nice smooth flow of refrigerant from a very small and compact compressor. Now this one really works good on the video to see it. This is a scroll type compressor, and I have another one here that it will move, but it gets stuck and it's very hard to see. So I have this one where the end is cut away. Again, this is a rotary compressor in that it has a nice smooth, and the pumping action happens while it is turning in a circle. And my gas is moving in here while it's turning in a circle. But if you look at it, we have one half of the scroll where it is stationary, and we have another section where it is mobile. All right. So as we roll this around, what happens is we simply trap refrigerant between the inner and the outer scrolls, and as we rotate it, it moves it around and from the inlet to the outlet. All right.